Today I'm going to GenAI DevCon in London to learn more about model merging. So what I know today about model merging is that it's like a collection of techniques to merge large models together, or to kind of get like different models together, or maybe the same model together, so that you can have a bigger and better model, but without training a bigger and better model. It kind of reminds me of ensemble models from the past, but I don't quite know how it works. So there's a ML scientist from Liquid AI speaking at this event today, and I thought we could learn a little bit from there. So the event is not until the evening, so I thought, well, I still need to go to work in London as well, and the building is pretty cool, so let me show you around, and yeah, let's go. We arrived with plenty of time, but the train is also delayed by 16 minutes, so I guess we'll have to wait. That's Google's new building. That's Google's old building. Lunch is being prepared. And this is the building. Now, this is the kind of thing I believe only London can have as an office. Imagine a castle, but it's an office. There you go. So Google is telling me that that's the place. I'm going to figure out how to get set up inside. I also realized I'm a bit late, so let's see how it goes. I also haven't eaten in a while. So I'm going to try and record as many clips as I can. I don't know how much I can record, but yeah, let's see. I'll see you inside and I'll see you back. Not here, but somewhere outside in a minute. And I'm back in Cambridge. I wanted to record at a place, but trains were getting cancelled and I didn't want to miss the last one. So I just came straight to Cambridge. So pretty good event. I was very impressed that the organizers came all the way from India to London to do this event. Met a few cool people. And I always come out excited to try a few things from events like this. So today I learned about Merge Kit, which I want to try very soon. But it's quite late now, it's past midnight. So I think I'm going to organize my thoughts, have some rest, and I'll continue tomorrow. And it's tomorrow. Okay, as I said, yesterday was pretty cool. I ended up meeting some pretty interesting people, including a senior Linux kernel maintainer, which was pretty cool. Like also a physicist, and there was like a good group of interesting people with different backgrounds. So that's very interesting. I also met Mike Taylor, one of the speakers, which I ended up buying his book. I'll leave some link in the description. He seems to be a really nice person as well, so that counts. So there were 3 talks. One on prompt engineering by Mike Taylor, and then one on improving your models. So that included the techniques like fine-tuning techniques, adapters, but also the model merging that I went there for. And then there was a talk on agents and kind of using agents at scale. So I went there to learn more about model merging, which I did. Actually, I did learn about MergeKit, as I mentioned yesterday, which is something I want to try very, very soon. So I'll leave some links in the description, but MergeKit encapsulates a bunch of these techniques for model merging. So my understanding right now, although I haven't tried, is that you can get started very quickly and you can get some models from Hugging Face. You can start trying to get them together. Now, I must say, I still, even after all, the talk, I still don't understand how model merging works. I mean, I understand what is being said in terms of the techniques, but I do not understand why, in the case, for example, there's a technique called pass-through, where my understanding is that you're basically just smashing a bunch of layers together. It could even be the same model. I don't understand how that would make the model better, if that makes sense. So if you see some of these like Llama 3, 120 billion parameter models, those are likely merged models. Now, they're not the same as training a 120 billion model, but they're better than the 70 billion, the original one. Now, I don't understand how they're better, and after talking to a few people in the audience after the talks, I think it's a shared, it's kind of a shared feeling, is that it's a cool area of research, but no one really knows how it works or why it works. And also there's some level of, in my opinion at least, some of the results that we're having could be a result of the benchmarks that are being used. So I'm not sure how they would work in practice if you're applying them to other domains. But anyway, it's pretty interesting ideas. So in the case of pass-through, you're smashing together a bunch of layers. I can see how that could amplify some of the values, some of the parameters, some of the weights. But for example, if you're merging two models, what I don't understand is, let's say that the models learn similar things from similar data. They could be learning it into different areas of the model. And if you smash them together, you kind of have multiple paths that the inputs could take, and they can get it confused. But the fact seems to be that it does seem to work based on the benchmarks. So anyway, I need to research more. That's the conclusion. But the like an interesting idea though, which it was not mentioned there, but kind of popped in my mind, was to use some of the work that Anthropic has been doing into studying the actual underlying beliefs. Do they call them beliefs? I'm not sure. But the underlying structures that the model is learning. And I wonder if that could inform a little bit model merging, or if at least we could use it as a way to understand what's happening after we merge the models. So that would be interesting to see. So maybe something to see in the future. So like I mentioned pass-through technique, but there were other techniques, and the other ones, I like the slurp one, where interpolating between things, I kind of, again, reminds me of ensemble models a little bit, without understanding too much about how either works. But that one I can kind of see how it would work if you're interpolating between two different things that may be good at different things. I wouldn't understand if that works for the model merged with itself, so that I would still be puzzled. But if you're merging two different models that were trained on slightly different training data, then I can see how that works. But again, I don't understand how that would work better than training the same model with all that data. I suspect it has to do with the fact that in the beginning, as a model, there's like kind of an optimal learning rate for the amount of data, and at some point the model gets to capacity, and what we're basically doing is just saying, hey, we've used two things that got to capacity, but together they can work well. That's the only explanation I have in my mind. If it does not make any sense, that's because it still is not clear in my mind. So anyway, I need to read more on this. That's the conclusion. I will want to try MergeKit, and the way I like doing things is like, actually, in the coming future video, obviously subscribe and like if you're interested in model merging or trying it out or see how it works. I'll be doing something in the future. But I want to take a more practical approach. So let's try and merge a couple of models, see what happens. So we'll need to come up with some benchmarks. We'll need to come up with some way of measuring quality. So let's see what happens. But definitely in the near future, I'll be looking to merge kit. Okay, then another thing that was mentioned is Q LoRa. I'm not sure how to pronounce, like the adapters, the low rank adapters. These can be pretty flexible, and they're also very cheap to run in train. So actually, this is probably the area I'm the most excited about. Model merging is cool in part because it just puzzles me as to how it works. But adapters, I think that makes sense to me. So you're basically just kind of doing little corrections to the model, right? You're just training, specializing something much, much smaller, but that attaches to the right places, I mean, ideally. And then a few properties of this that are interesting to me. So first is very performant. At least, I mean, it's not adding much more to the performance of running the model. Then, well, it depends on the size, obviously, but it's easier to train. So because if you're merging models, you still have to, at some point, to have trained those two large models. So this one is easy to train, and that means it unlocks this functionality for specializing or personalizing the model. So the idea is you could have potentially even small rank adapters. If you're building a product that has multiple users or multiple uses, you could have different adapters for each one of those people, specialize it, and kind of hot swap it. Again, this is just a way to customize behavior, and it reminds me more of a plugin system in traditional software. So I could see even a way to interact between different entities, like different companies, different developers, etc. If everyone assumes a certain base model, let's say Lemma 3, then a library of different adapters specialize on specific things for domain, that would be great. But also, if you're working with a company, this is probably what you'd pick to specialize in their data. Then this is a non-fact. Benchmarking is extremely important. I think benchmarking or evaluation in general. We've been getting by with the large models as they are today and the data as it is today, in part because it's so large and it's kind of, there was a lot of low-hanging fruits to collect, just a lot that the model could learn compared to what we had before. But I think now we're probably, I'm not sure if we're hitting a ceiling. I don't know enough to be able to claim that, but I would say that the improvement per compute unit is probably going to decrease. Unless, and this is the key point, unless we improve the data. So I think the data improvements, or if you're training your own models or fine tuning them, like having very high quality data for specific domains, so you can learn a lot more from like fewer examples. Understanding what are hard examples that you want to learn from, compares to just a different variety of examples. So anyway, it's something I still need to explore a bit more myself, but data and the data quality and the just studying of the data, improving the data, etc. I think that a lot more effort will be put there. Obviously, it's not as flashy when it comes to these types of events, so I don't think you'll see as many talks, but this is actually something that practically would improve a lot what we do. So I'll want to cover more in the future. So in the talk, they did mention that as models get smarter and smarter, the high quality of data will be even more important. Then there's also the fact that we're probably getting to the limits of the data that you can find for free online. So I actually spoke with a few people in the audience, that at least 2 or 3. And I think, I'm not sure if they're all from the same company, but maybe it's the same company. But I did speak with a couple of people, or 3 people that are working on startups about around licensing data for different companies. So this is both dealing with the legal side, even from publicly available data, but also doing deals with, like, private deals with other companies and getting some of that data out. I really liked speaking with them, so I'm quite interested to see what will come in the future. I do think that people who own data should probably be considering that has a lot of value, and they should not be giving it away today. So no, that's from a business perspective. I mean, ideally we would get a lot more open data, but I suspect as more people realize the value of data, maybe this is I would say a wild prediction. I'm not sure if I will put my money on this, but it's possible that we'll see some of the currently open data disappear a little bit into close data, or at least licensing being done differently. So anyway, so evaluation is probably akin to software testing, but in the case of ML is even more important because of the experimental nature of ML. Without evaluation or good evaluation, you're really kind of running blind. And some of the work mentioned by Mike Taylor on the prompt engineering mentioned that as well, like setting up evaluation and automatically improving prompts. So there's plenty of people doing the right thing. I think it will be interesting to see how this develops in the future in terms of tooling, etc. So my prediction is that common benchmarks, and we see them a lot in conferences or talks, etc. Common benchmarks are useful if you're comparing with other people, but more and more, I think it's a bit like software. Like we don't care if the software can be compared to other software quality. I mean, maybe it's a bad analogy, but the point is you want to more and more be looking at how do you create your own internal in-domain benchmarks. So this means even if you're doing your own personal projects, you want to come up with some idea on how to collect high quality data. I mean, hopefully without having to label the data manually, or at least not a lot of it. But you want to be collecting high quality data, creating your own benchmarks, etc. And so my point is that benchmark design and what it makes a good benchmark or a good evaluation set, that is going to be more important soon. And I'm not entirely sure actually how widely available that knowledge is at the moment, or how common it is. So then we go to the last talk, which I had a hard time following, in part because it was packed with information, which is a great analogy to the topic. So the topic was agents. I think today agents, at least to me, I only have a very, very, very extremely surface level knowledge of this. But agents to me are kind of a overwhelming word. So let me just close the door. Overwhelming words, in part because it feels like it's just an umbrella word for what if we put all the techniques we know about in modern LLM systems together, okay? And we call them agents. Okay, what if we also put a few of them together and let them interact? Now, that sounds in itself like, oh, that's pretty cool. But I think the problem with just being kind of a bag for everything is that it's also slightly underdefined and it's hard to understand who's doing what and what is happening. So I'm not saying that it has no value or less value. I'm saying that in a talk, it's just harder to communicate what's happening. So they talked about memory. They talked about how they kind of allow agents to talk to each other, etc. So there's kind of a communication layer. At the moment, I think a lot of it is relying on text, just free-flowing text, flat text. I would be very interested to see in the future using techniques like knowledge graphs or other forms of extracting knowledge that has, or maybe even causality, and have not just a log of the conversation allowing agents to communicate like that, but to also see what will happen if they can understand, if as they learn, a bit like what we do, they can relate concepts and share that knowledge with each other. Maybe that already exists. I'm sure that already exists, but I just want to learn a lot more about that. So but yeah, so I found it quite packed. They did mention one project I've seen in the past, and it did get me thinking. I'm traveling soon. I think this is maybe one of the projects I'll be working on as I travel. So what is the project? AI Town. Well, I'm not sure if that's the name, but it's basically a town built with AI agents. So you have like a little village, and you have a bunch of agents that go about their day of work, or I think the farmers, and then you have all these agents interacting with each other, but they're mapped as like individuals, not like agents that can talk like in the background. It's more the idea is just to model, I guess, a little town as a game. So I found that pretty cool. I mean, I used to work in games, so this always tickles me. So I think I will be looking into that if I want to look into agents. So anyways, as I said, like I always love these events because they get me very excited. So I think from here I got like merge kit to be tried. I want to try and merge two models and just see what happens. Maybe I'll try and break them in weird ways. Let's just see what happens. And then, okay, so merge kits, try a few things. Maybe I'll do 1 or 2 videos on this. And then adapters. Also, I think that is pretty clear that will be, well, it will be interesting to me. And then agents. That one, I think we can have a lot of fun. I'm not sure if they're very useful, but we can have a lot of fun. So, and I kind of like things that are fun, even if you don't know if they work. So, which I think the event kind of covered a good breadth of that. I guess when you're at the edge of development, that's usually how it feels. Like a bunch of these things, no one quite knows if they're already working or not, or how they would work, but they're cool. So we just do them. And maybe that's a cool thing about living in, not in London, but near London. I live in Cambridge. Yeah, you get to attend these events and you get to meet some interesting people. And also people travel to London from all over the place. I don't know if this was a good format for a video. I think, I mean, I cannot claim that this is different from the usual because I only have one. But in the coming videos, I will be returning to the previous format. So let's see. If you like this, please like and subscribe. That would really help trying to get this started. If you have any comments, any feedback, or if you just want to share any idea, anything about model merging, about anything I've mentioned, please comment. And I will see you soon. Bye.